Hello friends, welcome to Learner's Planet. Friends, this is our third session for sets. In the previous session, we discussed that's a union of sets, intersection of sets, and various other types of sets. We discussed empty sets, singleton sets. Okay, and in this session, we'll begin with some problems. So I just suggest you be ready with your paper and pen and start solving the problems right with me. Okay, so let's begin. Now in the last session we discussed intersection and union of sets. So based on the same concept we'll solve some of the problems. Here we are given the sets A, B and C, and we have to calculate A union in bracket B intersection C, right? So first of all, what you'll do, you will calculate B intersection C. That means you need to make a set which has the common elements between B and C. So let's calculate B union C. B intersection C. So B intersection C is, we can see only 4 is the element that is common, right? So there will be one element only, that is 4, that is common between B and C. 3, 4, 4, 5, 6. Now we need to calculate A union B union C, right? So in A we are having 1, 2, 3, and in B intersection C we are having 4. So A union, I suppose this to be say X. Okay, so now A union X is equal to all the elements of A and all the elements of X, that's just one element, that is 4. So A union X, or we can say A union B intersection is 1, 2, 3, 4. Okay, so option B is the correct choice. Similarly, we see this problem. Here we have to calculate A intersection B union A intersection C. I assume this to be X and this to be Y, and then we calculate X union Y. So first of all, X is A intersection B, right? So write down the common elements between A and B. So we can see 3 is there, I write 3. 4 is there, I write 4. 8 is not there, 10 is there. Okay, so I write 10. Okay, so that is A intersection B. Similarly, we calculate A intersection C, that is Y. So we can see 4 and 4, I write 4. Then we have 4, 5, 6, 12, 14 and 2, 3, 4, 8, 10. So we just have 4 as common between A and C. So A intersection B will be just one element, that is 4. Now we have to find out union of these two. So X union Y is equal to all the elements of X and Y. Now 4 is already there, so there will be just 3 elements, 3, 4 and 10. Okay, so X union Y is 3, 4 and 10. That is A intersection B union A intersection C. Okay, pretty simple. Though we have already studied disjoint sets, then also we just have a quick recap. Two sets A and B are said to be disjoint if A intersection B is phi. That means no elements are common between the two sets, that is A intersect A and B, right? Here you can see the universal set that is represented by this rectangle, and we are having the set A and set B, and you can see there is no intersection between these two circles, right? If there is no intersection between these two circles, that means there are no common elements between the two sets. Okay, so A intersection B will be a null set. Okay, so we call two sets A and B to be disjoint if they don't have any common element, or A intersection B is null set or phi. Okay, so A is 1, 2, 3 and B is ABC. You can see there are no elements common between these two sets. A is having 1, 2, 3 and B is having ABC. So no elements are common. That means A intersection B is phi, or a null set, and these two A and B are actually disjoint sets. Okay, and if A intersection B is not equal to phi. That means if it is not a null set, then A and B are said to be intersecting sets or overlapping sets. In that case, situation will be like this. There will be some common portion between these two circles. Okay, and the common portion represents the common elements. Okay. Now next important thing is difference of sets. Let A and B two sets. The difference of A and B is written as A minus B. Written as A minus B is the set of all those elements of A which do not belong to B. Okay, and now just see. These are two circles, and this portion is actually common portion, and this portion is A minus B. That means the elements which are there only in set A. A minus B is the element which are only in set A, and B minus A are the elements which are there only in set B. So this is what? This elements which are in only A, and this is only B. Okay, these are the elements which are common between A and B. Okay, so this is A minus B. These are the elements common between A and B, and this is B minus A precisely. Okay, so these are the elements which are common, or which are not at all common. These are the elements which are there only in set B. So that is actually difference of sets. Okay, so difference of sets, how do we say? A minus B's X belongs to A, but X does not belong to B, right? The element belongs to set A, but it does not belong to set B. Okay, and here you can see B, C is written over there, right? B raised to C is written over there. We call it as a complement of B. Complement of B, that means from the entire set. Okay, from the entire set, or you can say universal set, all the elements which are not there in B. Okay, I'll elaborate with an example, don't worry about it. Okay, so A intersection B complement. Similarly, the difference B minus A is a set of all those elements of B that did not belong to A. Okay, so A minus B is A intersection B complement is equal to A minus A intersection B. That means from the total set A, if you remove the elements which are common between A and B, then you get A minus B, right? You can see it over here. This is the entire set A, right? This is the entire set A, right? I am talking about this blue shaded portion. So what that is, from the entire set A, if you remove this common portion is what? A intersection B, right? So from this entire set A, if you remove A intersection B, then you get A minus B. That is clearly visible from here, right? Similarly, how do you get B minus A? From this entire set, this entire set is B. From this, if you deduct this portion is what? A intersection B. That is a common portion between A and B. So if you deduct this, then you get B minus A. Right, that is only B. So this is only A and this is only B. Okay, so you should be clear what is difference of sets. Not at all going to be difficult. I'll take one example to make it very clear. Okay, now suppose we have two sets A and B, right, and we have to find out A minus B. So A minus B, first of all you find out A intersection B. So A intersection B is the elements which are common, so that's 3. Okay, now A minus B will be all the elements of A which are not there in B. That means precisely A minus A intersection B. So A 1, 2, 3 and A intersection B is 3. That means A minus B will be just 1 and 2, right? That means the elements which are part of only A. Right, the elements which are part of only A. So this is only A. Similarly, we have to calculate B minus A. That means only B. So B minus A will be what? From the entire set of B, deduct the common elements between A and B. So entire set is 3, 4, 5. After out of that we have to remove 3. So remaining is 4 and 5. Right? So B minus A is 4 and 5. Only 2 elements. That is only B. That is only A. Right? This is only B. If you draw the Venn diagram, it will come up like this. That is A, B. First of all, you have to write down the common elements between A and B. So that is 3. I write 3 over here. Then the remaining elements 1 and 2. And here remaining elements 4 and 5. So you can see this portion that represents only B and this represents only A. So only A, that means A minus B, that is 1 and 2. Only B, that is B minus A, that is 4 and 5. So you should be able to draw the Venn diagram also, and you should be able to do the manual calculation also. Okay. Now R minus Q is the set of all irrational numbers. Now R is what? A real number. And Q is what? Rational numbers. So precisely what is happening? All rational numbers, suppose Q, plus all irrational numbers I is equal to all real numbers, right? All rational numbers plus irrational numbers is equal to real numbers, right? So if I deduct Q from R minus Q, that is from the set of real numbers, if we take out all rational numbers, then we will be left out with irrational numbers, right? So R minus Q is what? It is a set of all irrational numbers. Okay, rational plus irrational is real. So from real, if I take out rational, then I'll be left out with irrational. Okay, so that's very simple funda. So how do we calculate difference of sets? That I have explained, and I'm sure you are clear with this concept. Next is symmetric difference of two sets. Let A and B two sets. The symmetric difference is the set A minus B union B minus A, right? And it is denoted by A delta B. So precisely you can see the shaded portion over here. That's only A. This is only A and this is only B, right? So only A union only B will be symmetric difference. Okay, so that's very, very simple. I can take one example over here. So suppose 1, 2, 3, that's A, and B is say 3, 4, 5, right? So only A is 1 and 2. Only B is 4 and 5. Number 3 is common between the two, so I'm taking it out. Okay, so a union of all these is this, and that is actually A delta B. Okay, I hope you are getting it. Here I have given a solved example. Just see, A is this, B is this. A minus B will be what? Only A. So that is, we need to delete the common elements. You can draw Venn diagram also. That's A, that's B. First of all, fill up the common elements. We can see 3, 5 and 7, right? 3, 5 and 7. So 3, 5, 7. That's, this portion is A intersection B. So apart from 3, 5, 7, we have 1 and 9 in set A, and in set B 2 and 11. So this is B minus A, this is A minus B. So now we have to find out that's A delta B. So that will be A minus B union B minus A. So all the elements of A minus B and all the elements of B minus A. So that is 1, 9, 2 and 11, right? So that is A delta B, right? So that's pretty easy to calculate. I hope you are getting it. Now we discuss complement of a set. I have already used this term, but this time I'll elaborate what exactly complement of a set. Let U be the universal set and A is subset of U, then the complement of A with respect to U is a set of all the elements of U which are not elements of A, right? So complement of A with respect to U is denoted by A dash or A complement. Okay, so in symbolic form or set builder form, what we can say is X such that X belongs to U but X does not belong to A. Okay, so A dash is actually U minus A. Now you can see the shaded portion over here. This is the universal set. That rectangle represents the universal set, and this set this circle represents set A. Okay, so the blue portion that is outside the circle is actually A complement. Okay, or A dash we can say. We represent it as A dash or A complement. Just writing down C as a superscript we can say. So A, C, that is A complement or A dash, right? Now I take an example over here. Suppose the universal set is 1, 2, 3, 4, 5 and A is 2, 4, 6. So A complement will be just delete 2, 4, 6 from U, right? So that is A complement. So A complement will be 1, 3 and 5. Okay, so that's pretty simple. Precisely A plus A complement is equal to U. So A complement is equal to U minus A, right? That's very, very simple. Okay, all the elements of A plus all the elements which are not part of A is equal to U, that is universal set. So all the elements which are not part of A, how can we find it out? From the universal set, if we deduct all the elements, if we eliminate all the elements of set A, then we'll be able to get A dash, that is A complement. Okay. Now I take one example over here to strengthen the concept. Union, that is universal set is this, A is this, B is this. We have to find out A intersection B dash. So first of all we find out B dash. A is already given. B dash is universal set minus B. So 1, 2 of this from the entire universal set we need to delete 6 and 7. So we are left with 1, 2, 3, 4, 5, 6 and 7 we don't have to take, then 8, 9 and 10. So that is B dash. Okay, now we have to find out A intersection B dash. That means elements which are common between A and B dash. So now A is 1, 2, 5. So A intersection B dash is equal to the elements which are common between A and B dash. So we can see 1 is there, I write 1, then 2 is there, I write 2, and then 5 is there, I write 5. Right? So precisely A intersection B dash is 1, 2, 5. So it is actually A only. Okay? Because all the elements of A are there in A intersection B dash. Right? So A intersection B dash is 1, 2, 5. So that's nothing but A. Okay? Now let's discuss some results on complementation. Okay, and results you have to learn, but you should be conceptually clear why it is happening, right? Suppose we take the example, the first one, that is U dash is equal to X belongs to phi, and such that X does not belong to U is actually phi. Now why U dash is phi? See, U is what? Basically it's a universal set, right? This entire set is actually U. Okay, so this is U. So what is not there, that is in U, that's actually phi, right? So that is always a null set. So U dash is a null set because all the sets, all the elements will be there in this universal set. Okay, so which will not be there, that's just nothing will be there which is not there in set U. Okay, or we can say universal set. So U dash will be phi, that is a null set. Okay, similarly phi dash is what? That is U. So phi is what? Null set. So complement of null set will be what? U. So U dash is phi and phi dash is U. Okay, U dash is phi and phi dash is U. Phi means null set and complement of null set, that means all the elements, and all the elements means U. Okay, so U dash is phi, phi dash is U. Now A dash dash. First of all, A dash is what? That is all the elements which are not part of A. Elements not A, right? And if I take dash of it, now what will happen? Elements which are not there in A and that dash, that means element of A. Elements of A. Okay, so A dash dash is actually A. Okay, how do we do? X belongs to U such that X does not belong to A dash, right? Or X is equal to X belongs to U such that X belongs to A, and that is actually A. So A dash is actually elements which are not part of A, so that is A dash, and A dash dash is equal to elements of A. Okay, you can take simple examples to understand this also. I'll also be taking. Now A union A dash. So A is all the elements of A. I suppose this is a universal set. This is A, and this remaining portion is actually A dash. Obviously, because A dash is what? Elements which are not part of A. Now this is A and this portion is A dash. Now A plus A dash will be what? U, obviously. So A plus A dash, that means A union A dash. Plus means union, right? You are adding all the elements. So A union A dash is U. A union A dash is U. And A intersection A dash, see A dash and A, both of them are disjoint sets. Because what is A dash? That is all the elements which are not part of A, right? So A dash is a different set, A is a different set. So A dash and A disjoint sets, nothing is common between the two. That means A intersection A dash, nothing is common. That's why it is a null set. Okay, so you should be very clear about it. You are not asked in the exam to write the results, but you should be conceptually clear how these results are arriving, because these results will be used while you are solving the problems, right? Suppose you have to calculate A dash and a whole dash, then you can directly write the answer A if you know this result. Okay, so I hope you are clear with all these things, all this concept that we have discussed in this session. In the next session, we'll be taking more concepts, more problems. So do revise this session in the previous one. I'll see you in the next session once again. Bye-bye.